So we have some simple numerous examples here that is trying to test the first idea we looked at under the refractive expression for refractive index of a small amount of liquid in a concave mirror. So there are these three examples. Let's see how we can really analyze them and get their solution. Like if we are to look at number one, is saying that a liquid is placed in a concave mirror to a depth D. So I mean to a depth of 2 centimeters. And then an object held above the liquid coincides with its own image when it is 45.5 centimeters from the pole of the mirror. If the radius of curvature of the mirror is 60 centimeters, calculate the refractive index of that. Please, you shouldn't forget that we looked at this because you must understand the formula with the meaning of every expression in the formula. That point of coincidence of the image and the object measured from the pole here is what we are calling a H. Okay? And then the radius of curvature is what we are calling a R. And then D is the depths of the liquid. And we said we shall use refractive index of the liquid equaling to R minus D out of H minus D. That is a scenario where the depth is not negligible. Don't forget, in this case, H must strictly be measured from the pole up to that. Is that okay? So, let's now see how we can attack this question here. If I say a liquid is placed in a concave mirror to a depth, so that means that the depth of the liquid, D has been given to you as 2 centimeters. An object held above the liquid coincides with its own image. Okay, the point of coincidence is there. Its image, when it is 45.5 centimeters from the pole, measured from the pole up the point of coincidence, you will realize that that is our H that they are talking about as 45.5 centimeters from the pole. If the radius of curvature of the mirror is 60, that means that my R is 60 centimeters. So you can now say, using my refractive index equaling to R minus D out of H minus D, that means it is 60 minus 2 out of 45.5 minus 2. And please don't forget, in our calculation of light, however much we say substitution should be done in when we're having everything in a standard unit, but for light we basically use centimeters. So we don't convert that the unit of length should be meters. We only deal in centimeters. So this will be 58, okay, divided by 43.5. So what is our answer? Then you can get your calculator. I'm inviting you to get your calculator and then you tell us 58 divided by 43.5. And then that is 1.3333 recurring. That means that our refractive index here of the liquid is 1.33. Okay, so you say therefore the refractive index of the liquid is 1.33, like that. So that is the solution to our Roman 1. So let's then look at now Roman 2. I'm removing now this away, assuming that we have gotten it right. I'm leaving that diagram there to be helping us to make some simple interpretation where applicable to our numbers. And then I say that a liquid is poured into a concave mirror to a depth of 2 centimeters. Again here, the depth is 2 centimeters. And then they're saying that an object held above the liquid, considered when it is with its own weight is 27.0 centimeter. They are talking about an object held above the liquid considered with its weight is 27.0 centimeter above the liquid. So this 27 is above the liquid surface. What does it mean? They are talking about 27 being this. Different from this one, they said 45 from the pole of the mirror. From the pole of the mirror, they measured from this point to this point, and that was exactly our h. But if you realize that, if you see properly, you realize that this 27 is not measured from the pole, therefore it is not our h. So don't take it as our h, that h is 27. If it is h, if it is to be h, it should be direct from the pole. But for them, they're saying they measured it from the surface of the liquid up to that point there. So this one here, 27, is the same as h minus d. Is that it? Isn't this h minus d? Because the h is from here. But now they have given you this. Remember, this is the same as h, subtract away d. And that is what we are calling it 20. So you need to understand such a tricks. Is that okay? So 27 is from the surface. And we're saying for it to qualify to be called the h, it was supposed to be from the pole. So if it is from here up to here, and then we say it is not h equal to 27, but it is h minus d to remain with this depth here. Okay, we can then say if the radius of curvature of the mirror is 40 centimeter, r has been given as 40 centimeters, and then I say calculate the refractive index of the liquid, and then we still fall back and say using refractive index equal to r minus d out of h minus d, we shall say r minus d, r is 40 minus my d is 2 out of h minus d, that will be now 27. That means we are not supposed to subtract 2 again. Okay? We only subtract 2 on h if they had given you from the pole up to the point of coincidence. So if they give from here up to here, they have already subtracted the d for you. Therefore, you don't need again to subtract. So this is giving us 38 out of 27. What is the refractive index of our liquid? You can as well pick your calculator and then tell us what is trending here. My calculator here is telling me it is 1.4 to 1.40740. Okay? And I can say therefore the refractive index is 1.41. Isn't it? 1.41 or 1.407 as our refractive index. And that also will be the solution to our Roman 2. Then lastly, let's briefly look at how do we then attack the last question very fast, and we move to some other thing. So still again, the question here is telling us that a smaller concave mirror of focal length 8. They have given you focal lengths. This is now number 3. F4 has been given as 8 centimeters. But remember, in our formula of refractive index, we have no provision for focal length. Therefore, we need radius. Okay? We know that radius is twice f. So that means that my R is 2 times 8 to give me 16 centimeters. So, and I will use this to be consistent with my formula. R equaling to that lies a smaller concave mirror of focal length that lies on a base. A pin is moved vertical above it. At what point will the pin coincide with its image? At what point will the pin coincide with its image? If the mirror is filled with water of refractive index of 4 out of 3. You will realize one thing, that in all this statement here, we were not given the depth of the liquid, isn't it? And if the depth of the liquid is not given, and then that means that we should ignore it as being small. So I can say, let x be the distance for the point of coincidence. Okay? So we shall now say, as I've told you, that if the depth of the liquid is not given, please don't bother yourself and say, what about the depth? It may be a reason that the depth was so small in that they didn't include it in the question. So we shall use the formula of now R out of H, isn't it? Actually, let me be consistent by saying let H be the distance for the point of coincidence, isn't it? From the pole. So it will be now R out of H, isn't it? R out of H, because now we are ignoring the depth since it was not given. So that means that 4 out of 3 equaling to R, which is 16 out of H, implying that my H can be equaling to 16 divided by 4 out of 3. And this is H equaling to 16 times 3 out of 4. Reduce this one, that H should be equaling to 12 centimeters. And then you will now make a conclusion that therefore the height from the pole of the mirror where the image and object coincide is 12 centimeters. So that is how you can make solution to kind of problem like that. Please understand, don't cram, because they will try tricking you. And please make sure that you understand how this is derived, the meaning of every term, so that you can know how to use it well. Thank you.